Okay, good afternoon, everybody. Thank you for attending this session. My name's Matt Aslett. I'm the Research Director for Data Platforms and Analytics at 451 Research. And I'm going to be talking about next half an hour or so about the origins of big data and the term big data. And you just hear the big data myth. Just to give you an introduction for those of you who've not come across 451 Research before, so we're an analyst firm, an industry analyst and research firm. We were founded in 2000. We have over 300 employees, of which about 120 are analysts. We have over 2,000 clients in areas such as, obviously, technology and service providers, but also corporate advisory, finance, professional services, and, of course, IT decision makers. And just the last thing I'll point to on this chart, perhaps the most important, the next one, 50,000 plus. That's the number of people that we have in our research community. So those are not necessarily direct customers of 451 Research, although a lot of them work for companies that are, but they are IT professionals, business users, consumers, people who work with and use technology every day and help shape our perspective on the industry through doing surveys and interviews, and an increasingly important part of the 451 Research business. In terms of how our research and also data is delivered, as you can see, we have 15 different channels from the data center core, data center technologies, multi-tenant data centers, right out to the edge, mobile telecoms, enterprise mobility. And the area that I'm responsible for is pretty much slap bang in the middle there, data platforms and analytics. So I've been covering data platforms and analytics for 451 Research for the 9 years that I've been with the company. For the last 4 or 5 years as the research director, I'm also responsible for our overall coverage of that space. So as you can imagine, spent a lot of time in particular in those more recent years trying to articulate to our clients, trying to learn from our clients and articulate what the whole big data phenomenon is all about, and try and help our clients understand not just the technologies, but actually some of the processes and principles that they could put into place to be successful in their big data projects. And that's the first thing I want to just be clear about when we're talking here. You see the presentation title is talking about the big data myth. I'm not saying that big data is a myth at all. I mean, the sort of common use of the word myth is to describe a sort of a widely held view that is actually false. I'm not using the term in that way. I'm actually using the term in the original sense of the word myth, which was a story to explain why something exists, how something came to be. And in that sense, we look at the term big data specifically. It's all been about the words that begin with the letter V. And I've been to lots of events like this, and I've seen lots of people stand on stages like this and describe big data in terms of words that begin with V. And obviously, initially, we had the 3 Vs, and then it seemed like there was kind of a V-word-based arms race going on, and you'd come to events like this, and you'd have people talk about 4 Vs and 5 Vs and 6 Vs. I think the most I saw anybody genuinely try to present was 8 Vs. And you took a step back and thought, what on earth are we doing here? Are we really trying to describe something as important as this, as we think this is? This is a trend that we think is going to shape the future of not just this industry, but the industries as a whole. And yet we're restricting ourselves to words that begin with a single letter. Something's not quite right here. There are some reasons why we started off with the 3 Vs, though, and it all actually dates back to a research report that was published by another analyst, not someone from 451 Research, someone actually from another smaller analyst firm that was then acquired by a much, much bigger analyst firm that you will be well aware of. And they published a report back in 2001 that talked about the 3 Vs of data management. And it's a very good report, but it's talking about what were the data management challenges that faced data management professionals at that time and ongoing now. And they talked about that in terms of the 3 Vs, volume and velocity and variety. And then later, 2-3 years later, this concept of 3 Vs was then reapplied, if you like, to big data as being the framework for defining what makes data big data, its volume and its velocity and its variety. Now, there's a couple of issues that I had with that at the time, but kind of everybody was kind of caught up in this idea of defining big data in terms of the number of V's, and we were not immune to that. We talked about the 3 V's. We also talked about other concepts that go along with that. But there are some issues with this, and the first is that this report, as I said, was published in 2001, describing the 3 V's of data. But the phrase big data had actually been around since about 1996. It obviously clearly wasn't in as common usage, but it has been around since 1996. So there are at least 5 years when people were using the term big data and presumably understanding what they meant when they were talking about big data, and they weren't talking about any words that began with V, let alone volume, velocity, and variety. The second, and perhaps the most fundamental issue I have with 3 V's being a definition of big data is that the report that talks about the 3 V's of data management doesn't include the phrase big data anywhere in it. It doesn't actually include the word big in it. So I kind of have an issue with the fact that 3 V's defines big data when the document that talks about 3 V's doesn't talk about big data. So you may ask, well, does this really matter? Is this just a bit of professional jealousy on my part? We're just being a bit churlish to say, actually, it's not about 3 V's at all. It's about something else. I don't think so. I think it really does matter. And this is something we've seen, I'll talk about as we go forward here, with our clients, that it really does matter what you define big data as meaning. And we see organizations, it's important for them to define where they start with big data, because if you start in the wrong place, you're never going to get to your desired destination. And there are some great opportunities that lie with big data, but if you start with the focus in the wrong place, you may not get there. So how, if this is the case, why did we as an industry get hung up on the idea of the 3 V's being the definition of big data? There's a French phrase, as you can see here, my French is not the best, but déformation professionnelle, which doesn't, as far as I'm aware, have a direct translation into English. Kind of the nearest analogy I could get to was this visual depiction of if all you have is a hammer, everything looks like a nail. It's not quite that, it's a bit more nuanced. But essentially it is, if you look at the problem, if you look at data management challenges from the lens of what is the nature of the data, then by default, your solution will be driven by, or will be based on the nature of the data. So this initial analyst report, which, as I said, in and of itself is a great report looking at the data management challenges faced by data management professionals, and it absolutely very well describes those challenges, but that doesn't mean that it's describing the bigger problem. So I think if we want to understand what's going on with big data, the whole trend of big data and the potential that it has, it's actually necessary to take a step back from looking at the data and the nature of the data and understand what's happening in the context of bigger changes that are happening within the industry and the world at large. So one of the ways we can do that, and this is something that the World Economic Forum has done, and they're looking at here not big data as a singular phenomenon, but big data as part of the bigger picture, along with artificial intelligence and robotics and machine learning and industrial automation as part of what they term as being the fourth wave or the fourth industrial revolution. Then we see people talking about Industry 4.0, which is another term that we may all come to love to hate. But never mind, this, I think, is a good lens perhaps to look at what's happening here. And if we can look at what's happening in terms of revolutionary change and perhaps learn from previous phases of industrial change and industrial revolutionary change to get a clue as to what actually might be driving big data beyond the nature of the data itself. So just to pick a few examples, we can look at the printing revolution, enabled by the invention of the printing press, of course, but driven by the new economics of knowledge and education based on the product of that invention. We could step forward a few years and look at the British agricultural revolution, enabled in part by inventions like the seed drill, but driven by the new economics of production and food supply. Just a couple of years later, closely linked, We see the Industrial Revolution itself, the British Industrial Revolution, enabled in part by the invention of steam-powered machinery and other great inventions, and driven by the economics of manufacturing and transportation. Let's leap forward a few years, and we'll talk about the Digital Revolution, enabled by digital computers and the invention of the World Wide Web. And the illustration we have here is the early sketch from Tim Berners-Lee's paper describing the potential for the World Wide Web. And what we see is the change driven by the new economics of communication and commerce. And so we can kind of put data in that context. We think about the revolution, the data revolution, enabled by distributed computing and changes in advances in memory capacity and processor performance. Illustrated here by, this is an illustration of Google's search architecture. What we're talking about here really is fundamentally the new economics of storing and processing data. And it's that new economics of storing and processing data that we believe is at the heart of the trend of big data. And George Dyson, a computer historian, put it better than I ever could. And it was this quote which really sort of triggered off my mind of thinking beyond the 3 V's and thinking about big data differently. And it's that big data is what happened when the cost of keeping information became less than the cost of throwing it away. Now, you can argue about whether that's actually fundamentally true in every case, but why this is important to me is it gets to the heart of the fact that this is about the economics, the cost of keeping information. So we see that economics is really at the heart of big data. It's the economics of storing and processing data that led to the creation of Hadoop, the usage of cloud storage and NoSQL, new SQL databases, and the mass adoption, shall we say, of in-memory processor computing, in-memory data processing, and stream processing, not steam processing, as it says here. That's not annoying at all. I didn't notice that until now. Right. But it's that economics of storing and processing data that has driven organizations to adopt the workloads and applications that actually take advantage then of those platforms. So artificial intelligence, machine learning, predictive analytics, prescriptive analytics. It's the economics of storing and processing data that enables organizations now to take advantage of combined operational and analytic processing potentially in the same database. It's that economics of storing and processing data that enables the Internet of Things to be a reality. And it's that economics of storing and processing data which enables organizations to think differently about what they do with the data that's produced by the applications that run on those platforms. So we see organizations, we talk about this in terms of totality, just the sense of storing and processing all your data and analyzing all your data rather than aspects of it. We see organizations taking a much more kind of exploratory approach to analysis. Other people talk about discovery. Asking questions you've never asked before, enabling data scientists to really explore and mess around with data and come up with new questions rather than just asking the same questions you've always asked. And it's the storage and the economics of storing data and processing data that enables organizations to analyze their data much more frequently. To analyze their data not just at the end of the day or the end of the hour or at the end of the minute, but every second, thousands of perhaps, multiple times per second. Now we have to acknowledge the fact that obviously any of these new projects, new initiatives driven by economics don't exist in isolation. And there is an ongoing dependency that organizations have in the existing data processing and data management technologies. And economics has a role to play here as well. I mean, no organizations are throwing away their investments in traditional relational databases. They might be migrating away from them over time, but there's a sunk cost. There's a sunk cost in the infrastructures, there's a sunk cost in the software, there's a sunk cost in the skills. And we see that as well if we continue to broaden out the aspects of big data. We call this the total data wagon wheel. But the importance of skills, the importance of domain knowledge, of organizations having the ability to take advantage of the applications and the hardware and the platforms by applying the skills that they have, by applying the domain knowledge they have, and creating the business cases that will deliver value from the underlying technologies and capabilities. And of course, the all-important business case. Nobody gets anywhere without a business case, but the important point here is that that business case too has to be driven by the economics of storing and processing data. I talked before about, if you start in the wrong place, you'll never get to your destination. And it's increasingly become our view, and this is based on conversations we have with our clients, that if you start with the nature of the data, if you define your project by the nature of the data, its volume, velocity, variety, or whatever, then you start in the wrong place. That's what leads organizations to create experimental big data silos, which never really go anywhere and they can't prove the value of them, causes organizations to create not a data lake, but a data swamp. And we've seen some examples of this. A really good one, a few years ago, a very large, very well-known soft drinks firm came to us, and they'd realized the potential of big data. They saw the opportunity to store and process data that they hadn't previously stored and processed. And in particular, they saw the opportunity to go to their partners and to their suppliers and some of their regional organizations and gather data from the manufacturing process and the bottling plants. So they did that. They collected that data from the logs. They pulled it into a central resource, put it all into a Hadoop cluster. And that's when they came to us and they said, what questions should we ask of this data? And in particular, what questions should we ask of the data that will prove the value to justify further investment in this platform? And we obviously tried to help them as best we could, but ultimately it came down to, shouldn't you really have thought of this before you went out and gathered all this data and put it into this Hadoop cluster? And that's one example. But we've seen others, and we particularly see this, the potential for companies getting this wrong is even worse when you look at, companies trying to create a data lake, where they're treating, this Hadoop as a platform for pouring all of their data from multiple places without really necessarily thinking through why it's there and what it's for. So, it's our view if you start by, with the economics of storing and processing data, that it takes you that one step forward. It means that if you define in advance the economic aims of those big data projects, the potential value that you want to get out of those big data projects, then by definition, you've got your measure to define at the end of that project whether you can justify further investment in another big data project. So it doesn't become a silo, it becomes a series of big data projects which potentially can get linked together. And if you start by defining the economic value that you want to get out of the multiple applications that you will be deployed to run against the data in your data lake, then you're one step further forward in terms of identifying the application requirements, in terms of identifying what data needs to be in that environment and why it needs to be in that environment, and how you need to treat that data. For some applications, you need MDM capabilities, you need data quality. For others, you might not. But you need to define that up front. You need to have that understanding of the value of the project and define it on an economic basis before you start, rather than just defining it as being, here's a place to put all of our data. Back to the point here about, what I want to be clear about is we're not saying that big data itself is a myth. We clearly see there are huge opportunities for organizations to take advantage of big data. What we're saying is that that advantage is by default primarily economic. And we would see that big data is ultimately the attempt by organizations to gain competitive advantage by exploiting new economics of storing and processing data. There's a variety of ways in which organizations can do this. One is just about improving operational efficiency, effectively, doing what you do now, but doing it more efficiently. Doing things like optimizing marketing spend, accelerating regulatory compliance, streamlining internal processes, optimizing supply chains. And there's numerous other examples. But essentially, as I say, do what you do now, but do it more efficiently, using data to understand how you can improve the efficiency of those processes. The second is about creating new revenue opportunities. Doing things like improving product quality, improving customer engagement, accelerating time to market, and improving brand sentiment. Essentially, again, doing what you do now, but doing it better. Driven by data, driven by a better understanding of your product, of your brand, of your customer. And the third, and perhaps the most important or most significant, and this is where we see a lot of organizations are really ultimately trying to get to, is this idea of driving transformational change and actually driving vertical disruption. And the examples here are perhaps few and far between. And here you have to look at individual organizations rather than necessarily types of projects. But you see an organization like John Deere, for example, in the farming equipment industry for hundreds of years, now actually evolving to become a supplier of services and software to farmers, driven by the data created by the sensors that they've installed on that farming machinery. So still, obviously, very much in that farming machinery market, but actually evolving much more. The central focus of the engagement with the customers is about services and software driven by data. Similarly, General Electric, another prime example, obviously, again, for hundreds of years involved in industrial infrastructure, and now evolving, having spotted the opportunity to actually not just to actually generate revenue from the data being produced by that machinery, being produced by sensors installed on that machinery, and sell that as software and services to their existing customers and wider adopters of the Internet of Things. Other good examples, obviously, we can't go through a presentation without big data without mentioning someone like Airbnb and Uber, but Uber is a good example here of an organization that, having already disrupted the taxi industry, if you like, now moving into logistics based on having, accumulated data that will help them actually move into that environment and disrupt existing organizations. Another couple of examples, just more actually driven by acquisition, but data being at the heart of this. Look at Nike or Under Armour. Obviously, for many, many years, creators of clothing and sporting equipment, but now increasingly engaging with their customers via applications, via services that drive, basically fitness lifestyle. And then perhaps the best example I think I've seen is actually Netflix. And Netflix obviously, has already disrupted television industry by streaming other organizations' content to end users and breaking the relationship between the viewer and a particular channel or particular supplier. But actually using data to become not just to stream other people's content, but to create content of their own, and not just any content, but with House of Cards, an Emmy and Golden Globe winning television program that's driven entirely by data in terms of deciding what kind of program to make, what specific program to acquire the rights to, where to set it, where to actually film it, who to cast in that, all entirely driven by data, and has enabled Netflix to move from being, as I say, from being just a company that streamed other people's content to actually disrupt the television production industry as well. So there are huge opportunities. Obviously, as I said, those last examples are fewer and far between. Not every organization has the ability to evolve into a butterfly. As we say here, all butterflies used to be caterpillars, but not all caterpillars get to be butterflies. But clearly, all organizations are working towards that. And our view is, in relation to sort of that economic advantage that can be had from big data, the important thing is you need to start, as I said, with defining the economics of storing and processing data in relation to the projects that you're creating. So that's all time for the presentation. I think we've got a few minutes for questions. So, yeah, happy to take any questions, or we can follow up afterwards. Okay.
Hi, I'm interested to know, how do you decide what sort of research to do?
Sorry.
How do you decide what type of research to do?
How do we decide what type of research to do? That's a good question. Fortunately, within 451, we have an element of autonomy there. Obviously, it's driven by our clients. I mean, we do engagement with clients, inquiry calls with clients, so we understand what are the key things that they are interested in. We've always been an organization that, as I said, we kind of, with innovation being at the heart of what we like to cover. So essentially, if I see something that it's interest to me, I make the assumption it's probably interest to our clients, and we start looking at it. So for example, because of that, we started looking at Hadoop, I don't know, at least 2 years before some of the other analyst companies did, which are driven much more by what their clients are telling them they're wanting to buy. We started looking at NoSQL before any of the other analyst firms. Obviously, there's a balance there. We like to look at that, and we like to try and preempt what we think our clients would be interested in. But there is that balance then of understanding from them and the inquiry calls and as I said, the kind of the interviews and surveys we do to create more of a balance there. Okay. Any further questions? Okay. You get a couple of minutes for the next session, and you'll have time to set up your laptop. Thank you very much.